So this is the last part of the series of using collections in Java. In this video, we'll talk about priority queues or heaps and how they are used in Java. I'm not going to talk about how they are implemented internally. That is outside the scope of this video. But in this video, we would talk about like what are the common methods of priority queue that can be used in Java, and what are some of the common scenarios that we can encounter in a Leetcode problem. For example, like creating a priority queue for an array of m cross n, and we might need to sort it on the basis of a column value. So how can we do that? Creating a priority queue from a map and based on the key values. Okay, how can we use a priority queue as a max heap? Okay, so things like that. So let's get started. So let's see how we can use a priority queue in Java. So the class that we have to use is priority queue. Okay, again I would be using integer, but we can use any other type. Okay. By default, this is a min heap, so that means that this data structure sorts in ascending order. Okay, so if this priority queue will contain integer values, and they would be sorted in ascending order, and it maintains a ascending order. Okay, so it's a priority queue, so it's a queue with the notion of priority, means the values would be in some sorted order. Okay, so when we would kind of retrieve the values from this data structure, they would come out in a sorted order. Okay, so let's see that. So let me add some values. So the method that we can use is offer. Okay, so let me add some random values like 2, 4, 1. Okay, so I've added 3 values, and let me now try to retrieve these. Okay, so let me see, while, and here, so this is how you traverse, like you can, so I'm using an empty check here. Okay, so while pq dot is empty, what I would do is pq dot poll. So it's the same method that we use for a normal queue, is just that now there is like the values will come out in the ascending order because it's a min heap. So let's see, let's try to run it. Okay, so as you can see, the output is in ascending order, which was expected. Okay, so offer, like this method is used to insert the values into the queue. Poll is used to delete the values, and poll also returns the value. So this would kind of return the value that is on the top and delete it from the data structure. If we just want to see what is at the top, we can use a peek, just like in a normal queue. Okay, now let's move on to this one. We have to create a priority queue for an array of size m cross 2, or it could be of any size m cross n, based on second column values. Okay, okay, what do I mean is, like if it's a m cross 2 array, so there will be 2 columns, and I want to create a priority queue. I want to create a priority queue such that the rows are arranged in the order of the value of the second column. Okay, so let's do that. Let me copy over the array values. Let me just populate it with random values instead of items. Okay, so what I would do is I would use a class which is used to generate random values. This is called random, and what I would do is I would say arr of I j equals random dot next int, and we have to provide a value here which would be the range. So I'm giving 101 because it's just that like this range, this value would be exclusive. So what I would be getting is between, like below 101. Okay, so now what I'm going to do is let's just create our array is of 5 by 2. So I'm changing these loops. Okay, and now just try to I would just try to insert this array into the priority queue. Okay, so let's see how we would do it. First I have to create a priority queue, and I have to while creating the priority queue, I have to provide the information about like what value we want to keep the priority queue sorted on. Okay, so here we would be inserting arrays. So this is a 2D array and it's an array of arrays. So each entry would be an array in this priority queue, and so we would be providing a comparator. Okay, as how we want to arrange. Okay, so this is kind of a lambda expression in Java. So first of all, I have to change the type of the priority queue. That would be now integer array. Okay, and notice that although we cannot create a priority queue of type int because this is not an object, we can create a priority queue of integer array, which is an object. Okay, and as we have said before, we can only use the collections classes with the non-primitive type, that is the object types. Okay, so that's why an int array is an object, so it's fine to use it. And okay, and then after that we have to kind of provide the some way we have to mention like how we want to sort those integer arrays. Okay, so this is one of the ways to do that. Okay, so here what I'm doing is, this is a short way to write that I like while inserting I want to compare two array elements. So this is understood by Java compiler. We don't need to like mention the type and all here of these arguments. Okay, so we just need to say that okay, these types are understood to be integer arrays, and how do we want to arrange it? Like I want to kind of compare a1 minus b1, that is the second column value, and this would return a negative if like one of the column is like smaller. Okay, so and that's how the integer array should be ordered in this priority queue. Like that's what we are trying to say by this statement. Okay, if you're not familiar with the lambda expressions, I'll create another video where I would go like explain how lambda expressions work, what was the syntax and things like that. So stay tuned for that. But for now, I'm just going to use it. Okay, so let me just insert everything. So I would use a for each loop. I would do is I would say pq.offer a. Okay, okay, so I've inserted everything, and now let me try to poll everything and see if that comes in a sorted order by second column or not. Okay, so I would do it in a similar way, while not pq dot is empty. So if you want to be verbose, like let me try to write it like this. So I'm taking, okay, so I'm polling and I'm keeping the output in a temp, and then I'm going to print temp0 space and then temp1. So as you can see, this is our output, and it is sorted based on the second column, right? So this is the smallest second column value, then 45 is the next one, 45, then 49, and then 61. Okay, so this is how it works. Okay, if we want to change it, if we want to sort it by, let's say, the first column, then we just need to change this thing here, a0 minus b0, and let's see now. So 5, 38, 57, 68. So that's how you would insert an integer array into a priority queue and keep it sorted by any column or any value. Okay, this is a min heap, so that's why by default a priority queue in Java is min heap. It means it sorts in the ascending order. Okay, so that's why this column value is coming out in ascending order. Okay, so 5, 38, 57, this is like increasing order. Okay, we can also create a priority queue by like in reverse order. If we want to use a max heap, we just have to like kind of reverse this thing. Okay, so if I do b0 minus a0, that means now negative value would be returned when b0 is smaller. Okay, so if a and b are passed, so this would return negative when b is smaller. So that means that internally it would sort it as in a descending order. Okay, so let's run it and see the output now. So the first column value is in descending order, so 73, 71, 61, 14, 8. Okay, so this is now a max heap. Okay, so we just have to change the ordering of this subtraction here, and then it would change it from min heap to max heap. Okay, all right. And I have taken this example on a 5x2 or m×2 array. You can use, like, we can have any dimension to the 2D matrix, and we can sort it on any column value. Okay, all right. Now next one we want to see is, like, create a priority queue for a map of values based on a key. So now this says that suppose we have a map and we want to create a priority queue such that the values, like, I want to arrange the values in a sorted order based on keys. Okay, so also remember that if we want to keep the keys of a maps in sorted order, there is a different version, like we can use tree map directly, but just for the sake of demonstration I'm trying to demonstrate. There might be a situation where you have to like create a heap from a map, and you want to keep the keys sorted. So for that, let's see how we can do that. So I have created this map, and I have copied, like, I have just put some random key and values here. So I have created this map of integer key and integer value, and I have just added few, like 5 entries of key and values here. Okay, now how can we have to create a priority queue. Okay, so and what would be the type here? Now what would be the entry in a priority queue? It would be of type map.entry, right? So you can relate it with the previous example where our original object was a 2-dimensional array, and the entries in the priority queue would be of type integer array, right? Similarly, if it's a map, so each priority queue entry would be of type map.entry, right? So you can do it like this, and each entry here in this map would be of type integer comma integer, like key would be integer and the value is also integer. Okay, new priority queue. Okay, now we have to mention, like, we have to again provide the comparator here, right? So how can we do that? Now A and B, right? We can just simply say A and B, and we know that how we, like, what are these objects, what is the type of these objects. We know that this would always be same of, like, whatever is the type here. Okay, so these are like 2 entries here. Okay, so now what we can do, we can simply say, if we want to sort it by key, a dot get key minus b dot get key. Okay, so now this priority key would keep create a min heap based on the ascending order of keys. Now we just have to insert the map values. Okay, so let's do that. I'll use a for each loop. Okay, so entry set, and then what I would say is pq dot offer, okay, e. Okay, I'm just inserting each of the entries into this priority queue that I created. I'm just going to poll it, and I'll show you that the values come out in the ascending order. Okay, so let me just write it quickly. So while, so what I would do is, so this time I'm not going to create a temporary variable. What I would do is I would say pq dot peak, and this is the entry, so I would say get key. Okay, and then, so remember, peak would not remove it from the queue, but poll would. So first time, like, I would just peak and print the key, and then second time I would poll, and then I would print the value. Okay, so this would poll the entry from the priority queue and also kind of print the value. Okay, so let's run it now. So as you can see, the keys are in ascending order. So 26, then 36, then 39, 48. Okay. If I want to sort it by value, if I want to create a priority queue based on the increasing order of the values of a map, so what I would do is, instead of get key, I would just use value. Okay, and get value. Okay, and everything else would remain same. So let's run it. So as you can see now, the entries are sorted by value. Okay, so 16, 44, 52, 64 and 98. So that's how you create a priority queue. And also notice that this is a min heap, right? What if I want to create a max heap with map values? What I would do is I would just reverse this condition. Okay, so what I would do is I would say b dot get value minus a dot get value. Okay, and this would do the trick for us. So now see, the map entries in the priority queue are like sorted by decreasing order of their values. Okay, so 85 is the first entry, then 65, 40, 28 and 14. So these are the like frequent situations which you might encounter while doing your Leetcode programming. So you should remember these, you should know these. Okay, so that is it about the priority queue. Let's move on to the next topic. So our next topic is sorting. We would see like what methods are present in Java collections to sort an array or a collection. Okay, so here I've created an integer array, two-dimensional array, but this would also work for like one-dimensional arrays, and I'm just like kind of populating it with some random values. And then look here, what I'm trying to do, I'm not starting this time with very trivial example. Here again, what I'm trying to do is I'm trying to sort this array by, if you like try to think like what I'm trying to do here. Again, this is a two-dimensional array, and I'm saying that sort it, like the sorting order should be a1 minus b1, right? So what does this mean is, again, I'm trying to sort this 2D array based on the second column, right, in ascending order. So that's what I'm telling this sort function to do. Like, so whenever you're using, this is the function actually arrays.sort that you can use to sort any array. And when you do that, like you have the option to provide a custom comparator. Like comparator are basically the condition based on which you want to arrange your objects. Okay, and then I am doing like, I'm just printing out the array, and let's see if they are coming out in sorted order. So I've said like sort ascending on the basis of second column value, right? So you see second is first 1, 2 and 6. Okay, so this is working. So similar, like this is very similar to what we saw previously. If you want to like, let's say sort by the first column, you could just like do it like this. Okay, so 0, 3 and 7. Okay, so this is very trivial. Sorting a 1D array is very similar, arrays.sort, and then just if you want to sort in ascending order, you don't have to do anything. Like you can just simply do arrays.sort and pass the array ARR. Or if you want them to be in reverse order, you can just write a comparator and reverse this condition. Next one is like sorting a linked list. So the method so arrays.sort would only sort arrays, right? If you have different collection like a linked list, so we'll use collections.sort. So let me quickly try to create a linked list. So let me create an array list. Okay, array list of integers. So array list is similar to, array list is a data structure which is like a resizable array. Let's say you created an array list, and let's say in the library it is said that whenever there are more than 80% of items of the initial capacity, the array should resize. So it works like that. So let's say if you have an array list of size 10 and let's say the percentage set is 80%. So if you have like 8 elements filled, for the 9th element, like whenever we would try to insert the 9th element, what would happen is the array would be resized to double its size. Okay, so it works like that. So yeah, I'm just creating an array list. New array list. Okay, and let me provide us. Let's not provide a size. Okay. Let me add 10 values here. And how do we add? We would just say array.add. So this would append the values. Like this would add the value to the end of the array list, similar to like linked list.add method. Okay, so I would say random dot next int. So it's just inserting some random values here, and I have to sort it. So I would say collections.sort, and then I would just pass this. Okay. Now this is much easy to comprehend. So 0, 0, so array list is sorted based on ascending order. Okay. What if we want to sort in reverse? You know that just have to like pass the comparator here. Okay. So again, it's very simple. A, B. And what are A and B? What are the types of A and B? We know, the compiler knows, and even we know that this is integer, right? Why? Because ARR is of type integer, right? So we don't need to specify that, and we just like we have to do B minus A if we want to sort them in reverse order. So as you can see, 9, 9, 9, 8, 7, and this is in descending order. So that's about sorting. Let's move on to the next topic. So this last topic is about like how can you do a binary search using Java Collections API. Okay, so we have three methods. The first one is arrays.binary search, which takes an array and the key that we want to sort. And obviously the assumption here is that ARR should be sorted in ascending order for this to work. The second one is arrays.binary search, and it also takes ARR, and it also takes like beginning and end, that is a range, index values between which we want to do the search, okay, and the key. And the last one is like binary search on a list. So let's see that last one first. So I'm just using this code from previous example where I have just created some of the, I have created an array list and populated it with some random values. Let me do a binary search. But this is not sorted, right? So we have to sort it first. So we just learned how can we sort. Okay, collections.sort and then ARR. Okay, and let's print it out. Let me print the array elements so that we know. Okay, and then let me just try to search for any random value. Okay, so what I would do is I would use collections.binary search. Okay, so this is the method. Okay, collections.binary search if you are trying to search in a linked list or array list. The only condition is that this list should be sorted. So what is the syntax? So if you take a look at, so first thing, like we have to pass this ARR and the key. So how do we know? I don't know, like, because these are random values that I have inserted. So I'm just going to say that search for ARR 5. Let's see. Okay, so indexing doesn't work in array list, so get 5. So what I'm trying to do is, like, I'm saying whatever value is present at 5th index, just try to search it, because I don't know, like, all these are random values, right? So let's see what does this return. Okay, and let's take the output integer, so it should return 5. Value, okay, let me print a string, value plus ARR dot get 5. Present at index whatever val we got from this line. Okay, so let's search it. Okay, so this is not readable at all. Okay, now let's see. So the first line is about, like, first line prints the entire array list contents, and then I'm saying, okay, let's search for ARR.get 5. So what is present at the fifth index? So 0, 1, 2, 3, 4, 5, 6, right? So it says value 6 present at index 4. Okay, so you see, okay, there is interesting thing here, right? We said that search for the values present at 5th index, right? We passed ARR.get 5, but it says 4. Why? Because the value is same, right? And so this binary search, collections.binary search, returns the first occurrence of that number. Okay, so since 6 was present at both 4th and 5th index, so that's why it returned the index 4 here. Okay. And this is similar, this behavior is similar when we use like arrays.binary search, beginning, end, key, all those things. So let's quickly take an example of arrays.binary search with this index. Okay, so so this is sorted by default, right? Because we are just inserting the indexes, so no need to use like sort again. Okay, this is fine. What I would do is I would say arrays.binary search. Okay, and then let's search for 8. Okay, let's see if that the 8 is present or not. Okay, so let me just kind of modify it. Value present at index val. So I'm just now printing whatever index is returned by the binary search. Okay, so 0, 1, 2 and all this, like 0 to 9, that's what we inserted, and then we searched for 8, right, which is present at the 8th index, right? 0, 1, like you can do a counting, it's the 8th index. What if like we want to search for a value which is not present here, for example, let's say 100. Okay, so it will return some negative value, minus 11. Okay, so any negative value, not necessarily minus 1. And also, like if you don't this ARR, if this is not sorted by ascending order, the binary search would just return any random value, okay, which is not correct. Yeah, let's take an example of like passing the keys, okay, and see if there is a key. Like I want to search within a particular range. Okay, so I would say I want to search between 2 and 7 index, and then I want to search for, let's say, 5. Okay, so 2, 7 and 5. Okay, so from index to index and the key, and let's see if these whether these indexes are inclusive or not. Okay, so let's try to read about it here, or we can also like test it through the code. So it says from index, the index of the first element to be searched, to index is the index of the last element, exclusive. So it says that the last index is exclusive. Okay, so which means this would be searching from 2, this would be looking at whatever key you want to search at, 2, 3, 4, 5 and 6th index. Okay, so let's see. Okay, so value presented index 5, but if I pass a key like, let's say, 8, although 8 is present in our array, but here, since we just want to search between 2 and 7, so this would not be able to find it. So it says minus 8, right? It just returns some negative value. Okay, so that is it about using the binary search library method, and that concludes our video series of like going through the Java important methods of like Java collections API for the Leetcode. There could be like other methods which are useful, and you might like encounter them while coding, but these would be like the most common methods, and these are the must-know methods to code in Java on Leetcode. Thanks for watching. Stay tuned.